Alright, so today we'll talk about our next chapter, which is chapter 9. In this chapter we will talk about the perimeter, area and volume calculations of different objects. Alright, so how do we start? We talk about first about the planes. See, all the objects that we have in front of us which has two dimensions, especially let's say the flat surfaces you have, like the floor, like this surface on your table. These are actually the two-dimensional surface because they have only two sides, width and length. And intersection means whenever two lines intersect or two planes intersect each other, they cross each other, right? And parallel means something that do never intersect with each other. For example, the rail lines, you see, they always go, side by side, but they don't ever intersect. And they have the same distance every single point, at every time. And the degrees are an angular measurement. I'm sure you have heard about the degrees because we use the degrees to calculate the angles for different objects. And the circle is actually divided into 360 equal degrees. That's why any circle is called 360 degree at the center. Just like that, your center of the circle where you actually have 360 degree, if you take a quarter of a circle, it will be 90 degree because you divide the circle into 4, right? And similarly, the half of the circle will be 180. We'll show you some examples and pictures. The angles we have in different places, like in different objects, like in triangle, different other objects, they have different measures based on the degrees, right? For an example, we have some angles, those are called right angles. They are always 90 degrees. Most of the cases, the planes that intersect each other and form a 90-degree angle are said to be perpendicular on each other, okay? Like these ones, right? Perpendicular on each other because they actually create 90 degrees, right? All these are 90 degrees, right? All right. And whenever you talk about any plane shapes or flat shapes, they are actually two-dimensional, right? And most of the common planes are some of these, like rectangle, square, triangle, circle, right? So we'll explore most of it today. This is actually a rectangle which looks like a soccer field, right? It has four sides, and the parallel sides or opposite sides are actually equal in length and parallel also. And also four sides angles measure 90 degree at the corner, right? And these are called the diagonals, these lines. These diagonals actually intersect at the center, right? If you basically connect the opposite corners, that basically makes the diagonals, and they meet at the center here, okay? I'm talking about these lines, okay? These lines. And also, the diagonals are also same in the length. If we have something similar to the rectangle, but all the sides are equal in length, that is called a square. And every other rules you have in the rectangle applies except the sides are same, right? All the sides are equal in length. The triangle are actually three-sided. They have three different sides and three angles. These are some examples. And no matter how you draw a triangle, it will be always add up to 180 degree, okay? So we have different types of triangles based on their sides. One is equilateral triangle that has three equal sides in length and it has three equal angles. As you know, the triangle has three angles. All the angles are equal in this case. Isosceles triangles have two sides equal, but two sides are the other one is not. Similarly, two angles are equal. Scalene triangles have no side equal, no angles are equal, but all of these triangles actually will have 180 degree if you add their angles, okay? Triangles can be also classified based on their angles, because so far we did the classification based on the sides. You can always classify it based on the angles. If you have a triangle where one of the angle is 90 degree like this one, like this angle here, This is 90 degree, right? If one of the angle is 90 degree, that is called right triangle, okay? Because this is actually a right angle, right? If your triangle has one right angle, it is called right triangle, okay? And the opposite of that right triangle, meaning this side, is the longest side of the triangle, and that is called hypotenuse. Okay, this longest side. Okay, this is called hypotenuse. And this right triangle has an extensive use in applied trig. We'll be talking about the applied trig next class, which is actually the beginning of the trigonometry. Okay. But all the trigonometry discussions are mostly based on the right triangle. So that's why the right triangle is extremely important to understand. And also, if you look at here, we also call this, if you just start at this point and then go all the way to the top point of the triangle, this is called the height of the triangle. Similarly, this is the base of the triangle, this length. Okay? And the other side, which is actually this side, is actually the longest side of the triangle, which is called hypotenuse. Okay. So we're still trying to classify the triangle by their angles. So we have one triangle that is called oblique triangle that doesn't got any 90 degree, but again all the angles will measure 90 if you take the total. Oblique triangle can be also two different types. One is called obtuse triangle, which is where you have one angle which will be more than 90. For an example, this angle is actually more than 90, right? Similarly, you can have acute triangle where none of the angles are actually more than 90. But no matter how you see or what you see in the triangles, what properties they have, but they always have one single property that all the angles will actually add up to 180 degree, no matter what classification and how you actually classify that specific one. This is exactly what we are talking about right now. And also, if you actually take the half of any square or rectangle, that will end up having a triangle. Okay. So that's why any rectangle or square actually have double of angles of a triangle. If the triangle has 180 degree, then rectangle or square will have actually 360 degree in total if you add the angles, meaning 4 angles. Okay. Let's try some quiz question here. A triangle has 3 sides, right? A rectangle has 4. Square has 4 as well. For a rectangle, each inside angles measure 90 degree, right? So the right answer is B. For a triangle, the inside angles add up to 180 always. That's the right. That's C. If one of the angles in a triangle is 90 degree, the triangle is said to be an or a right triangle, right? If one of the angle is 90 degree, that means you have one right angle, and that triangle is called right triangle. Okay. So here we have a circle. As you know, as I said before, the circle, this is the center of the circle, and at the center you have 360 degree created. So if you divide the circle into 4 equal pieces like these, each piece will have 90 degree at the center, right? And by definition, there are 360 degree in the circle. And then if you just start at the center and go to any direction following a straight line and go to the circumference, which is actually the border of the triangle, right? Then you will end up having the radius, right? That means this length is actually called the radius, starting from here to here, okay? So from center to the circumference, if you draw a straight line. But if you draw a straight line from one side to another side, and that line basically passes through the center, that is actually the diameter, right? Now again, diameter is always twice as long the radius, as you can see, because it's actually the double, right? So if this is the diameter, that is actually the double of the radius. Okay, or I can say radius is actually half of the diameter. Okay, and and if you take the relation between the circumference and diameter, because this C means circumference, which is actually the border, the length of the border of a circle. If you take the ratio of C and D, that will be always equal to pi, no matter how you draw the circle. Remember the pi, you have the calculator, in the pi, you have a symbol pi, right? The pi is a constant, which is actually equal to 22/7, which is actually a repeating, which does never stop, which is a fraction, but we try to round it up to 3.14. But this ratio is always will be the ratio of the circumference and the diameter of a triangle. Okay. Okay. So, and again, we try to simplify it or round it up to 2 decimal points, and this is still not, not complete, but that's actually 22/7, which is the ratio for circumference and diameter. We use a Greek symbol like this to, or sometimes write pi to denote that this ratio. We can also measure the angle of a triangle by another measure called radian instead of degrees. In that case, we say 2 pi radian equals to 360 degree. That is actually the relation between the radian and degree. Okay? That means we call at the center that we have 2 pi radian instead of 360 degree, but it's exactly the same thing. It's just like 2 different measures. Okay, so that's why 2 pi radians and 360 degree are actually equal. Okay, and we can use this as a conversion factor. Remember, in one chapter we talked about the conversion factor, where we can convert between units. Similarly, we can always convert between angle and radian using this formula. Okay, let's try some quiz question again. The diameter of a circle is half of the radius, right? No, it's actually twice the radius, right? So the right answer is B. Diameter of a circle is twice the radius. How many degrees we have in a circle at the center? 360, right? Right answer is D. The radius of a circle is, again, twice. The radius of a circle is half the diameter, right? So right answer is A. So we have a term called perimeter, which is actually the boundary of a plane shape, basically, which means the distance around it. So we can draw some polygons like this, where we have some straight lines on the boundaries like this. As you can see, it has actually how many sides? 4 sides, right? So this is called a polygon, right? It can has 4 sides, 6 sides, So, and then you can actually add up the lengths of the side and then get the perimeter, right? So for an example, it has 4 sides. If you just add the length of each side, that will basically give you the perimeter. Okay. And similarly, using this, because all the objects, the regular shaped objects like rectangles, square, triangles, those are actually sort of polygons. So we can use the same formula to calculate it. For an example, in case of the rectangle, we have 2 lengths and 2 widths, right? So that's why we add 2 lengths plus 2 width to basically have that full perimeter. Okay. So we have a multiplication here, right? 2 times length plus 2 times width, right? Just to make sure, yeah. In case of the perimeter of a square, we can say 4 times the side, because all the sides are equal. You can always add side plus side plus side plus side, but that's 4 times side. Perimeter of a triangle, you add actually 3 sides. Perimeter of any sort of triangles, like for an example, you can always add 3 sides. This is the equilateral triangle. Since all the sides are equal, you just multiply the side by 3. But that is still s plus s plus s. So if you have some irregular triangle shapes, like irregular or polygons like these, you can always add their sides, right? Okay. So maybe let's say this is a floor plan of any polygon, right? So you can always add their sides and find out the unknown sides from the other information given. We'll show you some example. For an example, let's say you are given this one, how you can find all the sides. For an example, you actually don't know this side, right? But you know the total length from here to here, which is 20 feet, right? From the information given in the left side, this is actually 20 feet, right? Now, if this is 20 feet from here to here, this is actually 12 feet. So the remaining part would be actually 8 feet. And similarly, we did it here as here. I wrote it here, right? 8 feet. And also, if you don't know about this side, right? So, but if you know from here to here, starting from here, if you go all the way to this side up to this point, that's actually 28 feet, right? But from here to here, you don't know it, but you know from here to here, that's actually 10 feet. So if you subtract 28 feet minus 10 feet, the remaining will be what? 18 feet, right? So now you know all the sides. If you add up all the sides, you'll actually get the perimeter. So whatever you will have, sometimes you may not have all the sides known, but using the known ones, you can always find the unknown side, and you can add up all the known and unknown sides, once you know all the sides, to actually get the total perimeter of any irregular polygons like this. Okay? And we can always check and double check this one. Let's try some quiz question here. The perimeter of a square of 4 inch in each side, what will be the perimeter here? You actually add the 4 sides, right? Which makes it what, 16? 16 what? Inch, right? So the right answer is D. You are not changing the unit actually in case of perimeter, because you are not working anything with the units. But make sure all units are same when you add the perimeters of all the sides. Perimeter of a rectangle, 4 inches width and 5 inch tall. Remember 2 times length plus 2 times width. Now 2 times width is actually 8 here, and 2 times length is actually length is actually 10 here. So right answer is 18, right? 2 times 4 plus 2 times 5. The right answer is C. The 3 sides of a rectangle measure 3 inch, 4 inch and 5 inch. If you calculate the perimeter, it will be actually, you add all the 3 sides, which is 12 feet, right? So right answer is A. So if you have one prime like this, that means actually feet, okay? If you have double prime like this, that actually makes inch. What is the perimeter of a square 6 meters on a side? You just multiply 6 by 4, right? Which makes it 24 meter. So right answer is B. What is the perimeter of a rectangle? 1 feet width and 10 inch high. Now in this case, be careful about the units, because the first one is given in foot, second one is given in inch. You have to have everything in same unit, right? So 1 feet is actually 12 inch. So you have actually 12 inch here. So 2 times 12 plus 2 times 10, which makes it 44 inch. Okay. So B is the right answer, but if you can convert, you can check that other ones, 3 feet 8 inch and 2 feet 20 inch also equivalent to 44 inch. You see what I'm saying? So actually all of these are actually the good answers. So the right answer is actually D in this case, because all of the answers are right, except the way we have written, because we have just written in different units, but they are actually equivalent. So the right answer is D. Let's look at how we calculate the perimeter for circle. We have two different formulas. One is based on the radius, other one is based on the diameter. If you calculate using the radius, it will be 2 times pi times r. Remember, the pi is a constant, right? 3.14 in short, but we have, we have some longer values of pi. We cannot, if you divide 22 by 7, it never stops. So if you keep, you actually keep dividing. And similarly, using the diameter, you can use just pi times diameter. You still get the same answer for the perimeter calculation of a circle. Okay. For an example, if you have a circle of 12-inch, the 12-inch actually is the diameter. That's, let's say, the circular flower pot. That means 12-inch is actually the diameter. If you multiply pi times 12-inch, then you'll get 37.7, assuming pi is 3.14. Right. Let's calculate. Let's try some quiz question here. What is the perimeter of a circle of diameter 1? 3.14, right? Because we just multiply 1 times 3.14. So the right answer is A here. If the diameter is 5 feet, what is the radius? Remember, the radius is actually what? Half of the diameter, right? So the right answer would be 2.5, which is C. If the radius of a circle is 5 feet, diameter would be twice, right? That means 10 feet. Right answer is B. If you have to find the circumference of a circle, you multiply the radius by what? 2 pi, right? Remember the formula 2 pi times r, if you know the r, right? So the right answer is A. If you know the diameter, you actually multiply the diameter by only pi, right? To get the perimeter, so the right answer is B. Okay. Now let's try some quiz question based on these formulas. This is only one quiz question based on this formula. Now, what is the circumference of a circle with radius of 2 meter? What is the formula? 2 pi r, right? The r is 2 here also. So it will be actually what? 2 times pi times 2, right? 2 times pi times 2. That means 4 pi. That means 4 times 3.14. So I guess the right answer would be 12.6 meter. Right answer is D here. Now let's look at how we calculate the area of the objects. So far we tried to calculate the perimeters, which is actually based on the border, right? Or the boundary of the different objects. The area is actually a measure of a surface of a plane. For example, you are standing on a floor, you can measure how big the surface is based on the area. So the area calculation you actually multiply. That's why your unit get multiplied as well. So the most of the area, in area calculation, your unit get multiplied. So your units will be square feet, square inches, square meters, right? All sort of square things. Sometimes you can write only feet square or meters square, right? For an example, if you have a rectangle subdivided into some units like this, you can think like this. Let's say, for an example, in this direction you have 7 units. In this direction you have 5 units, right? But if you multiply 5 times 7, you will see 35. But if you look at the total square here, you will see there are actually 35 squares. That actually is a measure of the whole area. Okay? That's what actually you do, because let's say if this 1 square is 1 square inch, total will be what? 35 square inch, right? These are some formulas to calculate the areas of different shapes. Remember the rectangles. The formula is very simple. You just multiply length times width. Formula for calculating the area for circle. I'm sorry, no, so for square. This is the side. That's only s square. If you just multiply side times side, that is s square. And this is for the area of the triangle. Remember, the triangle has a base and a height, right? So this is like half times base times height. We'll show you some example, of course. This is the formula for calculating the area of a circle when you know the radius, pi r square. But if you know the diameter, the formula is a little bit different. It's pi d square over 4. Okay. But sometimes you can, estimate the difference of the object better by counting the number of circles inside the object, because if you assume one of these is like 1 unit, you can actually count the unit here, and you can count the unit. I'm saying approximately you can guess that how different they are, just calculating the the total unit they have inside. But that will be you will be getting the same information from the formula as well. Okay. For an example, if you are trying to estimate the number of tiles you require, for an example, 1 tile means 1 unit, 1 square inch. Let's say if you want to estimate the number of tiles you require to floor a room that is 36 feet by 42 feet, how you calculate the area of the room? All you have to do is just choose the right formula. You have to first see how the room look like. Most of the cases the room should be a rectangle, right? For an example, the room we have is a rectangle because if you see the opposite sides are parallel, you have 4 sides. In that case, you just multiply their sides, right? Length times width, which is 32 times 42 here, and you will get 1512. Notice we also multiplied the unit here. You see what I'm saying? You actually multiply the feet times feet. That's why you get a feet square here. Okay. So that means it would take 1512 1 foot square tiles to float the room. Meaning, if one tile is 1 square feet, you actually will need 1512 tiles. This is a big room. Let's look at some quiz question here. What is the formula to calculate for calculating the area of a square? This is a square, right? Side times side, which is s times s, because it's the same side, right? So right answer is C. How to calculate the area of a rectangle? Length times width, right? Right answer is A. Formula for triangle, half times b times height, right? Right answer is D. When finding the area, the answer will always be in what unit? It will be always in square, right? Because you'll be multiplying the feet twice. Feet times feet, or the meter times meter, something like that. So the right answer will be C. What is the area of a room 20 feet by 15 feet? You'll actually multiply both, right? Which will give you 300 feet square. So the right answer is D. Okay. What is the area of the triangle with a base of 2 and height of 4? Remember the formula, half times base times height. If you multiply all of these three, half times base times height, right? That's the formula, right? Half times, what is the base here? 2. Height is 4, so that becomes 4, right? Meter square. So the right answer is A. How about the area of a circle? I'm sorry, area of a square, 8 meters on a side. So you have 8 times 8, right? 64 meters square, because all the sides are the same. Right answer is A. Now we look at some solid shapes where we have three dimensions. So all the see it will be like some solid, like the soccer ball, right? all the three-dimensional objects you can see around. They have different shapes, and based on the shapes, they have different names. Some of the shapes are very common, right? For an example, here are some common shapes like prisms, cones, cylinders, spheres, and we can show you some example on how they look like. For an example, this is one of the common shapes. This is called a cube. As you can see, it has 6 sides, right? It's like a dice. 6 equal faces, and each of the faces is like a square. And this is a cylinder. I'm sure you all have seen the cylinder. It has 3 dimensions, and as you can see, the cylinder, the top and bottom, they look like circles, right? And there's a height here. You can, soap can might be an example. There are plenty of others. All the pipes, right, like cylinders. So this is like a teepee. It's called cone. One of the side look like a circle, and other side actually meet at a point, right? Taper to a point, right? So this is called cone, right? These are some common shapes. There are some more common shapes, but we'll talk about the volumes of this common shape. The volumes actually indicates how much capacity it has, meaning how much thing or like air it can actually contain. And the volumes actually is a multiplication of 3 dimensions, and that's why all the units will be actually cubed. Meter times meter times meter, right? Feet times feet times feet. So that's why we call it feet cube, meter cube, or cubic feet. 1 cubic inch is actually like this one. If you all the sides here, like this one, this side, right, and this side, and this side, all the sides are equal, then actually you can think this is a 1 cubic inch, because you are multiplying all these three dimensions, right? That's how you can guess how big will be 1 cubic inch. These are some formulas to calculate the prism. Prism is actually a rectangular shape, right? Like for an example, a very good example of a prism might be a book, right? Rectangular prism, because if you see the book, all the sides are actually like a rectangle, right? All the sides look like a rectangle. So you just multiply their 3 sides, length times width times height. If you have a cube, it will be just all the sides are equal. You multiply 3 sides, s times s times s, which makes it s cube, right? Oops. These are some more formulas. This is the formula to calculate the volume for the cone. Remember the cone? Here r is actually the radius of the circle at the bottom, right? And we have also the height. Similar, we have the formula for the cylinder. This is the radius. We have 2 circles, right? And both of the circles are the same circle. So the radius is actually one of those circles. It will be coming from one of the circles. And height is also multiplied. The last one we have is actually no, not the last one, but the next one we have is the sphere, which looks like a globe, right? The world, the earth, look like a sphere, right? To calculate the radius, we use the formula like this. The only thing that you need is the radius to calculate the volume. This is like a this is an example. Let's try this example and see. Calculate the volume of the pop tent. Now this is a pop tent here. You can see that one of the corners, one of the sides is actually a triangle, and then you have a height. All you have to do is just calculate the area of the triangle and multiply with the height. You are actually multiplying 3 different sides, and this is the formula actually, right? So if you do half times b times h times d, this is half, b is actually the base, height is 4, and this is the other side. You are just multiplying all the sides with half. That's how you get 60 feet cube. That's how you actually get the pop tent volume, right? This is another example where you are calculating this is like this is a cylinder, right? I'm saying this looks like a cylinder. This is actually a storage tank which looks like a cylinder. You have two different circles, right, in two different sides, and this is the formula. So all you need to have is the radius and the height, which is given to you. Since the diameter is 14, the radius will be what, 7, right? Half of the diameter. So you got it here, and this is the height actually, or length, however you think. Because if you think it is laid down like this is length. If it is like vertical, it is height. But that's the other shape, other dimension. So you just multiply the height, which is 20 in this case, and then you get the answer, which is feet cube, because you actually have 3 dimensions multiplied. Let's look at some quiz question. When finding the volume of a container, the answer will be always in what units? Always will be cube, right? Because you are calculating the volume and multiplying by 3 dimension. It will be always cube, meaning cubic meter, cubic feet, all those things. You have a square box of 1 feet on side. If you calculate the volume, you'll be multiplying 1 feet times 1 feet times 1 feet, right? That will be 1 feet cube. Right answer is 8. Let's say you have a rectangular box with a width of 2 feet, length of 4 feet, and height of 3 feet. How do you calculate the volume? Because the volume is actually the capacity of the box, right? All you do is just multiply 3 dimension, right? 2 times 4 times 3, which will be 24, right? 24 feet cube. The right answer is D. D is the right answer, right? This is the last question for today. We have a pop 10. How do you calculate the volume for the pop 10? Pop 10. Half times all the 3 dimension, right? Now this is going to be half times 3 times 7 times 5, right? That's actually 52.5 feet cube. So the right answer is B. Any question here? Let's go to the quiz section and let's try the quizzes for chapter 9. This chapter is extremely important because we have a lot of applications of this chapter, and some of the concepts of this chapter is actually the base of the applied tree, which we will be covering in the next class. Okay? So let's go to the quiz section and try all the quizzes for chapter 9.